First of all, I'll introduce myself. I'm Deepali Trivedi, and I'm platform architect for Staples.com. And this session, as part of this session, I'm going to share my learnings, my experience, what we did at Staples, and the general application of NoSQL technologies for scalable e-commerce platform. So if you are here from last 2 days, you heard a lot about all these different vendors and companies who actually either write the products, NoSQL databases, or they provide the services, right? But this session is from the different angle. It's from a user. If you're part of if you're a developer, architect, manager, executive at any IT company, and you are looking at NoSQL, hearing a lot about it, how do you start? I mean, you have scalability issue. You are not that happy with other things, but how do you really start and make a change in your organization? So this is more from the user point of view, and how do you apply, how do you change your mindset when you start working with NoSQL technologies or big data, and specifically about the scenarios where it can be helpful. I mean, it can't solve each and every problem that is there in IT, but it can be applied to specific areas, and it is really helpful there. So I'm going to share that. A few years back, when I started to hear a lot about big data and NoSQL and MongoDB, Cassandra, everything, I always thought that it's more for search engines and social networks. I mean, it's not for at that time, I think I was working with Pearson in learning and education domain. I thought, yeah, it's great, yeah, very good, for PhD students and for search engines and social network. But as I was introduced more and I started using it, and one day, we really decided to go with it. After using it for a few years, I realized that it can solve problems in any domain, actually. So I personally use it in a learning context and educational websites, identity and authorization, and e-commerce for sure. So, and that's why I thought I should share share with everyone that this can solve problem in many other areas. And just to give some background on Staples, I mean, how many of you know Staples? I hope everyone, right? How many of you buy from Staples? Or check out on Staples and go online and buy it? For Staples, forget about the retail, just looking at Staples.com, it's the second largest website in terms of revenue. So of course, scalability is the biggest challenge, or one of the key areas, stability and scalability. Especially when the holiday season will come, Cyber Monday, Thanksgiving, I mean, that is the focus, scalability and stability. So I just start with some of the context around e-commerce. And if you buy online, I mean, you know what e-commerce is. So I think it's not a new domain. But just from the data modeling point of view, I always think of e-commerce as 3 key entities. And you can disagree with me. But I mean, I always see it revolving around user, product, and order. So for user, why user is important? Because they are going to pay for it, right? They are going to buy, and you are going to get money from that. And we run a lot of analytics and a lot of logic off of user and what they buy. So we divide the user in all these different segmentation. Oh, this is the user. This is a set of users who buy electronics. These are the users who will generally go for all the printer-related stuff. And we target them with different promotions and couponing and ads. So that's why this user, and there is a lot of things. I mean, I just try to capture the main entities, but there are a lot of other entities that goes with the user. Product, and again, for the use, as I said, we do a lot of things with user, and I mean, there are many users who are the client of the website. I mean, we need scalability for this part of the system. Now I go to the products. The product is all the SKU or SKU set that we sell in e-commerce website, and it is part of category and catalog. Ideally, product should not need that much of scalability, because there is a fixed set of SKU or SKU set that you are selling. But with this whole change with marketplace concept, we are allowing all these other vendors to come to our website and sell their stuff. And that's why there are huge number of SKU and SKU sets on the website. And that's why even product is an entity that needs scalability for e-commerce. If I go to the third one is order, and you can tie it to the shopping cart, because we do a lot of things with shopping cart as well. But the order is the final key when you get the money and you do the checkout, and it has all the integrations with the backend system and fulfillment system. And inventory check and reserve online pickup. So all of the things are tied to the product order. So that is the last push that's needed to finish the transaction. And order is the place where you really need the transaction. So we'll visit that in detail, how it works out with NoSQL. So this is the very basic data model for e-commerce. If you, and some of the slides, I mean, I'm just trying to capture the key aspect of the NoSQL adoption. Like, if you are coming from SQL background, like many of us, right? I mean, I'm coming from SQL background. I studied normalization to that during my engineering, and then used it for 5-7 years, and I thought I was expert at like doing the normalization. I mean, I can work with business analysis for a few hours and have a perfect data model using normalization. And one day my world turned upside down, and there is no normalization. I have to think from other way entirely. So, and that's why I think when you are, as a user, as an architect, as a developer, going to adopt NoSQL coming from SQL background, this is the key. You have to just forget about having this normalization and start thinking about, like, you have to try to merge all your data and try to see like very few number of tables or very few number of core entities. So just take the example of user, right? So if you do normalization, like relational database, you will create one table user and put first name, last name, other attributes there. When you come to address, you will see, oh, address, if user can have multiple address, so I should put it in a separate table and have some references here. For user segment, again, it's a separate table. No, it should not be here. It's a data replication. So we'll put it in separate table. And whenever we want to get the information across the entities, we'll try to do joins and then get the data. That is the usual way, right? Now forget all about it. Go to the NoSQL, and you have to start with this flat entity. So you have user, you have first name, last name, address. When you go to address, address is the nested entity of the user entity. So you don't create a separate structure for that, separate document for that, but you embed that and you call it nested entity here and you put it there. The same way, all the segmentation, users who buy it, printer, this, that, everything you try to put it here. I mean, I should not say everything, otherwise you will have just one document for the entire table or entire schema. That's not the way. And we'll go to the next one there. So when we started doing it, we argued a lot. Should we really put user as the nested entity of segment, or should we put segment as the nested entity of user? And I try to find some guidelines, like how do we decide per case, right? I mean, I can tell as an architect, oh, for this scenario, this makes sense, but why? And how do you repeat that for development? So I think many others are also calling the same thing as question-oriented schema design, right? You work with your analysts, you work with business people, you find all the action that end user will take on your website, and then you try to identify inputs and outputs. So ideally, you are trying to identify the queries that will run on your system. The key here is that all the parameters of the query should be part of one document or one table or whatever you call in NoSQL terms, right? If you are doing column-oriented, it should be part of that one structure. How to decide nested entities. So just 2 examples, and maybe that can give you some answer. So if you are trying to figure out, most of the time you are trying to figure out what are the products viewed the most in last week, then you start with the product, and the viewed by users are nested entity as viewed by, so that you can run the query efficiently. Or if you are interested in what are all the products viewed by the particular user in last week, you are trying to target the user, then you can start with the user and put viewed product as the viewed column there. So, but the key, you can do mistakes here. I mean, that's fine. But the part that is important is that all the input and output parameter of the query should be part of the one structure, and that is the key here. So sometimes as a user, like as user of technology, you don't really care too much, like how Java does the JVM, how they put the variables in heap and all that thing. Like you really sometimes don't really care how does all these databases share the data in these different partitions, and like you want to know limited amount of knowledge so that you can do your work, right? You don't want to know each and everything about that technology that you are trying to use. But there are few things you really have to understand about NoSQL before you start using it. I mean, you don't have to know each and everything, but there are 2 or 3 key concepts when you design your system using NoSQL, and eventual consistency is one of them. I mean, if you are attending all the sessions, I mean, you must be expert at eventual consistency. But we have used a relational database for so long that we take this ACID properties or transaction management as like default, right? We think, oh, it's always there. But it's not always there when you start with NoSQL. So you have to understand whatever NoSQL technology that you choose, you have to understand whether it have eventual consistency, like weak consistency or strong consistency, like how does it work out, and you have to design your scenarios accordingly. Just to give you a very, very basic example of eventual consistency, what it is, and this is a little bit of non-commerce example, that if you have an account in bank with $100 and you open two browsers and fire the event at the same time and try to deduct $60, if that bank website is using relational database, it can throw error for one of the transaction because it's real-time consistency, yeah, immediate consistency. You can get error in one of your sessions that you don't have enough amount and things like that. But on the other side, if you go to ATM, right, if you some way you try to deduct the $60 or $70 from two different ATM, at that time you can get the money, but eventually you will get some message alert and your account will have minus balance. Because ATM is a different transactional context, so it can't really have global transaction across website and ATM. So, I mean, at the end, after some time, after delay of few milliseconds or second, it will match up, but it won't be the real-time consistency. In e-commerce, where it's important, like inventory check, right? If there is only last printer left, and there are two users who are trying to buy the same printer, one of the users should get an error. But it might not happen in that way in real time if you are using NoSQL. So you have to design your system that way so that you don't really deduct your money before you know that there is a printer result. And I can discuss that part in detail at the last. But I think we struggle a little bit when we try to design some of this type of scenario that really need transaction management using NoSQL. Okay, so again I said sometimes you really don't want to know where your data is stored, right? But one key concept that you should know about NoSQL is that all of your data, all of your tables are not in one server. It's actually divided, it's partitioned, and it's sharded, and it is on this different physical server. It makes the life of your IT department, like infrastructure team, very easy because you don't need one beefy server, right? I mean, you can have like few commodity server and you are good to go. So it's good in that way. But just on the logic side, you have to understand that your data is divided here, and that's why that is the reason why you can't do the join with NoSQL, right? Because the part of your table or part of your documents are divided everywhere. So ideally, you can't really do the join very effectively. Mostly you are coding at application layer, but you still have admin and others who are dealing with this configuration and this logic. So that is one more key aspect of it. So just to recap on design guidelines, you have to think about aggregation and nested entities over join. Whenever you say your data is not normalized, you have to be okay with some kind of data duplication, because normalization is good at that. It will avoid the data duplication. But when you are saying that it's denormalized, there can be some data duplication in your system. You have to understand eventual consistency. Actually, you have to understand the cap theorem. You have to understand you can't get everything. You will either get any two out of consistency, availability, and partition tolerance. So most of the NoSQL technologies let consistency go and focus on availability and partition tolerance. So whatever technology that you choose, you should understand what is the trade-off that you are making out of these three. And then sharding and linear scaling. I mean, sharding is the mechanism, but what you get is linear scaling, which is the key benefit. If I'll go up, how do you really build the e-commerce data model, right? You decided you want to start with NoSQL, and you did some presentation, and your VP or director, everyone is, oh yeah, let's do it. How do you really start doing it? And I think there are many other steps in between that. But I think this is a little bit from the SQL mindset, but still if you follow this, you will get the initial data model for your NoSQL system. So first of all, you have to identify the operations that end user will perform on your website. you identify all the entities that is referred by that operation. And then you identify the attributes of the entity in context of this operation. And then you identify the relationship between these entities, and then you repeat this for all scenarios and combine the design at the end. So the example here, very, very basic operations for e-commerce: find product by category, or add product to the cart. So find product by category, it will refer to product and category, or add product in the cart will refer to shopping cart, and what are the attributes that is needed there. So for product is name or SKU, items in stock, price, category, etc. For categories, ID, name, or list of products. Cart, same here. Now, what is the key? As I told you, you have to think about all the parameters needed for each operation, and it should be part of the same structure. So you said find product by category, so you need all the input and output, all the attributes of the product and category in context of that operation part of the same document, and that's how you can match your data model, whether it will work at the end or not. So you can see here product will have SKU, name, price, size, whatever is the key entity for product, but it has category as well, so that you can actually run the query and find product from the category, or you can find the categories of that product. And the cart, so add product to the cart. So cart will have all the cart attributes here, but at the same time it will have product that is added to the cart, what is the total of it, what is the user that is owning the cart, things like that. Same here for the user. You have all the user, but at the same time you have segments or products that he bought, cart that he have, things like that. And again, I told you, right? You have to match. You have to look at each operation or each query and see whether you can find all the answer of that query from any one of your documents. And this is more documented oriented, but you can do this in.
Why is a cart separated document from user? I can see over here for user you have a
yes.
cart also. Are you duplicating, or are you
yes.
just putting the
duplicating? So if we are running a lot more analytics and a lot more query on cart, just the cart. So every time if we go through the user, it will add some delay to that. So and here for the cart we will not have everything. It will have only a subset of the attributes that is needed for here. But this card will have everything. And that's why I said when you do the denormalization, there will be some amount of data duplication. You can decide. I mean, it's always a trade-off. If you don't want that duplication, you have to be okay with running the query in certain ways. And okay with that. If I go to the next one, again, I mean, if you have used any of the NoSQL, I mean, this is no-brainer for you. But I still wanted to give you some real queries or example how it can apply to the e-commerce domain. So for example, find product by SKU. That is still, oh yeah, that is correct. So I'll say that is like db.catalogs.find. And so, I mean, I'm just trying to show how different or how similar it is to SQL. Update the cart, so it will have some kind of push addition or append kind of thing to the cart, and it will increment the subtotal and things like that. Find the user by zip code. This is interesting, and again, this is a whole new topic of using Hadoop, but and we'll visit that. But how can you? I mean, there are few operations, there are information that is data intensive, right, and time intensive, and that doesn't really work out well for real-time queries. But if you want to see some of the trend long term, we really need analytics, and we need some other mechanism. So this is the example for that MapReduce. If you want to aggregate all total orders by zip code, you want to see how effective our website or our campaign or our couponing in this one particular region. You can do map and then reduce and try to run that on orders and find like number of orders by zip code. Actually, if you want to do this for last 2 years, you really need MapReduce. But if you want to do it for shorter time period, like 1 month or less than that, you can still do it with this kind of query. It doesn't take that long. So again. because I showed you a lot about MongoDB, just to give another variation of data modeling for e-commerce using Cassandra. And I mean, Cassandra itself a big topic. I can't explain you column and column family and super column family here. But I always think of Cassandra as a recursion of table, right? I mean, if you have one table and you just take out one column and put another table there, I mean, that's how I always think of Cassandra data model. And so here I tried to capture the user as a part of a super column family. So each user will make one row. So each row consists of one user. So that is the key, user one. The value will have again a column family. And in that column family, the first column is products bought, and that will have 2 products. Then cards that will have products and total both. Again, the second row is user 2, and the user 2 is the key, and again the column family there. So that is how you can do it, and then you have to figure out the whole new syntax for your queries and things like that. Headup will remain the same. Okay. So next I'll go to analytics, but what I want to say for just on the NoSQL part is that as part of this presentation, I'm not trying to take a stab at best NoSQL technology for e-commerce. I mean, I don't think even I have expertise or even there is a finite answer in industry for the best NoSQL technology for any domain per se. I mean, you have to look at your use cases. I mean, I don't think there is any e-commerce platform can decide one day I want to rewrite whole system, whole site in NoSQL. You really can't do it. You have to think incrementally. So you take subsystem of your website, you take one component, try to use NoSQL and put it out there, see how it goes, and then, so migration is a whole new topic, and you learn from your one implementation and apply it everywhere. And it's, I mean, we are coining that idea, and I don't know how everyone feels about it, that maybe we can use different NoSQL technology for different subsystem of our website. We have to see how that goes, but it's hard to find one NoSQL technology that works for every scenario for such a huge website. So that is just to share some of the thoughts that is going on now for Sam. I don't have that many slides, so if you have a question, you can ask me.
I have a question.
Sure.
Kind of back on the thing where you said I have the 3 different ways of looking at the data, I've got the user, blah, blah, blah. And so I have this product, and you had paper, and it was $24. And, but you now have a price increase, $26. So does it happen such that if I happen to have gotten in at the $24, then my shopping cart will say $24, even though somebody else who may have come in, because of the fact it's not consistent across, they will come up with the $26.
Yes, so when you don't have consistency, like immediate consistency, this can be one of the scenario. And what we argued at that time is that for staples.com and many other websites, they don't really change price in middle of the day. They do it like one batch at the night. So anyways, we are not doing it real time, so it doesn't matter. Like we can invalidate all the web session at that time whenever we change the price, or we can do some logic there. Like doing that one-time thing is easier than doing it like for every second, right? So then we thought we are just arguing, or we are worried about the wrong problem, and that was the conclusion. Because generally there are not many sites who will change the price in middle of the day.
Okay, but also I have price here, I have price here, I have price here. And from a data management point of view, how do you know that those are all priced, that it's all the same thing?
And so in one system, there are different prices you're talking about?
No, in your system, you had basically 3 different documents, all had price in it, but you know that those all mean the same thing, those all mean price. From a data management point of view, how did you know that those are all the same price? How do you keep it consistent that they're all called price?
Yes. So actually for most of the e-commerce website works this way, and our website also works this way, that we have a different subsystem that we call PDB, like product data management, and we store all the pricing information there. So most of the price that we'll copy is the done product orders that we'll save the price for, but ideally we won't have the real price fitting into our NoSQL store. So PDB is an entirely separate subsystem that runs entirely in different what do you call, it runs out of the website and it just have the integration. So every night it will push the data. After that, the data is read only. So in our website, wherever you are seeing price, it's read only. It's most of the time it's all done. You know, either a user already bought that product, that paper at that price, and that's why that price doesn't matter, or that is the price for that day. And at the night it will be pushed again.
What happened in the morning?
Sorry?
That's what you want to ask.
No, it's one of those things where you kind of say, I'm going to work on the price document, right? You're going to go work on a different document, the order document, and he's going to work on the third document, whatever it was. If we're not talking, how do you know to call it price when I call it price and he knows to call it price? How do you keep track of that?
So every night the data will be pushed and all
No,
the
but even when you defined it, even when you said this is the data that I want, how do you know that you should be calling it price? Maybe you say, oh, I want to call it sale number or whatever.
No. So and that's why we have to decide on this first, some basic structure of the document. Otherwise, all these different people will refer to these prices differently, and then they can't really. Yeah, definitely. We have to come up with, and that's why I know theoretically we can change the structure anytime we want and all that, but it doesn't work out that well with real scenarios because you have your analytics running on that. Today, suddenly I decide, oh, this is not price. This is my sales price. It won't work for analytics, right? Because it's running off of that, or some other tools that is running off of that. So yeah, theoretically, yes, I can still change my document structure and my website will still work, but it will mess up something, and that's why I'm putting a lot of emphasis on this data modeling. Ideally, if you really go to any NoSQL tutorial, anything, they won't talk about schema. They don't talk that much about data model because it's flexible. You can change it, agile, but it doesn't work in real scenarios. I agree with you totally.
Okay, but do you have anything that you kind of either kind of do someplace else or something?
Yes.
That you keep track of? Price is always called price?
Yes. So this is our take that for e-commerce, 80% of transaction is read only. User will just go browse, and then they will buy. So what we are trying to do is that we are trying to use NoSQL. We are thinking about using NoSQL in those read-only scenarios instead of write-intensive scenarios. And that's why wherever we are writing the price, that system is still SQL. And then we are pushing this here, and then everything is NoSQL, but it's all read, So we don't have to worry that much about consistency.
Got it.
So, yeah.
It's not fully NoSQL.
Oh yeah, and that's the thing I said, right? I mean, we are, maybe at the end I should say what is actually we are doing, what is the plan to do, and what is actually done. We can't really take our whole website. I mean, it's not possible to take the whole website and do NoSQL, right? We are just trying to look at new subsystem that we are writing. For example, reserve online and pick up in store. Okay, so we are trying to look at that and trying to see how we can use NoSQL in that scenario. So it's very small subset of thing, but we are trying to think about like this big bang just to get an idea how it works out, how can we do data modeling, how does it look like, and what are the areas that can give us the pain points. So that is sure.
So you talked about data being pushed, right? When write happens somewhere else and the data gets pushed over. So have you had any concern over how long that takes and whether you need to bring some pieces of the system down when that happens?
So today it works that way, and it works really well. So every night something will run, and it will load the data, but it will be enabled exactly at midnight or some point of time. So it will be loaded first, but it will be like enabled for everything like at one particular like 3 a.m. in the morning. So that, I mean, we are not really worried about the loading part, like how long would it take and things like that. Not worried about that part.
Okay. So basically, getting the data across all the nodes and all, it's not really that big an issue.
There are few things that is tricky there, but overall, no, I don't think it's that big of it because we are doing it one time. Yeah, sure.
What is the usage of your NoSQL DBI? I'm still not able to understand. Are you
Yeah,
using
it's
for
not
analytics,
heavy for
or are
staples.
you using for posting?
So
your
and maybe we'll go to the next one. So we are looking at the NoSQL technologies for a few specific areas, whatever the new areas that we are, and more on analytics side and more on, I don't know how much you know about staples, but we are using IBM Commerce as our core engine. So but we are trying to come up with all this new subsystem on cloud and open source and using NoSQL. So that is the new initiative, and we are thinking about all this for that.
Is it for order management, posting real-time transactions?
No.
So these are not your actual documents for cart management?
Oh, no.
This is just an example, right?
This is not just the
This is
example, but
nothing
this is
close.
this is some of the blueprint of the things, and once I'll get more feedback, that can help us deciding the directions.
Quick question. I agree with being used 80% of the time, but then in order is made, the data has to be stored in the NoSQL, and for persistence, it has to go and either get stored in Hadoop or in your relational database systems, right? So for that system to understand that the order is coming from this particular user, it has to be mapped. This ID has to be tracked with that system, right? So how do you do that?
Very true, and that's the problem going with the subsystem, right? If you just decide to do NoSQL just for one subsystem, all your other relational system need that foreign key that you are stuck with. And that's why you have to have that foreign key, and you have to have something which will map your foreign key with this user ID, whatever you are talking about. And that's one of the biggest challenges we are seeing with this subsystem design and with this migration and things like that. And that's why we are trying to go with the systems first that doesn't really deal with these core entities, but it will have some, like I give you the example, right? Reserve online and pick up in store or something like that, which is really a top layer on the core website. And
so as of today, you have some kind of a mapping table which maps this NoSQL unique keys with your relational database unique keys?
No, not today. Not today. This is the plan. This is not in production. But we have done very similar at Pearson. I have done very similar at Pearson, and where we are trying to just take the user, just the authentication part, and map it with MongoDB, and everything else was in relational. But that was true SOA, so we never had the foreign key. It was vertically partitioned, so only there was a separate user schema and web services that we could replace very easily, and user was interacting with all other entities via web service, and that's why it was easy to really take that subsystem and rewrite it using NoSQL. So if we have the application like that, it's easier to just take one part and rewrite it.
So I have a question. You have a user's entity, and over there is a product spot. That's one-to-many relationship. So is that product spot only for that particular session, or it is also the history also over there?
So you have to decide if you I mean, actually on our website, one user don't buy that many different products. They buy the same product in repetitive quantity, right? Like paper, so they will buy the same paper, but like every month, or like they buy the quantity will matter, but not the total number of products they bought is really that different. But if there are like large number of products bought by one single user, we have to decide like how much data we want to store for that immediate system, and how much data we want to store for analytics and long-term data. So I mean, if it's something like Amazon, they can't really store all the products bought by that user in your immediate schema. So you can decide how much data you want to store.
Do you guys take the data from the NoSQL store and merge it with like the order data, for example, which is maybe stored in a SQL store, and send it to Hadoop for large-scale aggregation?
I tell you one thing, whenever we start this migration, order, either it will never be turned into NoSQL, or it will be the last thing to turn into NoSQL, you know, so that's for sure. For now, there is, order is something that, anyways, it's a subsystem. We are using Sterling for that, so it's more like a SaaS-based vendor product for us. So we are not looking at that, but we know all the transactions and complexity around consistency will come into picture when we go to the order, and that's the, we are not worried more about the checkout and everything, because it's all we just punch into Bank of America and get something out. So we are not worried about that part, but we are more worried about the inventory and few other things that really is transaction.
It's actually more downstream towards Hadoop. If you're joining the order data from your SQL store with the stuff in your NoSQL store, and you know, sending all that stuff downstream for Hadoop processing.
We are not doing it now, but that's the one area we are thinking a lot about. So here, right? So what is I think I just ran out of time. But what is more important for e-commerce, on one side you have all your sales data, right? On the other side you have all your couponing and promotions and ads and everything. How do you correlate that? And I mean, you want to you just don't want to give away your stuff, right? You want to sell it at the price where user will buy it, but you still make the profit out of it. And that's why all this cross-channel analytics is the key. Today for IT, the problem is that there are many ways you can sell data, and there are many ways you can target user. Retail, tablet app, mobile app, web, then web store. There are global other, like Staples have 34 presence in 34 countries. So how do you really reconcile all this data, and how do you see what is effective and what is not effective? And that's where we are struggling. I mean, ideally we can really plug into all these different SQL and write one centralized SQL database, or have some ETL and EDW, but it makes it very, very brittle, because if retail or if website will change the data model, all this ETL and everything has to change, everything has to go at once, and it's not scalable. I mean, we get the data like 10 days back, but what if we want to use the data from Black Friday on Cyber Monday, right? I mean, we really need near real-time data, and that's why we are thinking about using Hadoop. And if all the system can send that text output or logs, server logs, etc., and we can feed into the Hadoop cluster and run some MapReduce or Hive, because we still want to store our data long-term in SQL if we really want to, or something like that. We can still read this text file and have some dashboards, reports and everything out of it, some conclusion out of it. And I think that implementing this will be easier than changing the core website into NoSQL. And this will have immediate success or immediate benefits in terms of that. I don't know how, I mean, in the end, I want the feedback on all these things, because we are going to build that. And we are thinking very seriously about that part for sure. Again, I said I'm not going to compare all these NoSQL technologies, but just very, very basic overview of challenges, advantages and disadvantages of SQL and NoSQL. I think asset properties and this transaction management is the key. We are so used to it, and there are many advantages with it. So that is definitely the plus on SQL side. But on the disadvantages, I mean, how many of you have tried how many of you get this push from your management that we should do zero downtime deployment? And always, like, DML changes are always complicated to manage for zero downtime deployment. Like you really want to run this DML queries and then fill the previous data and fix the other data, and then that's kind of complicated. So it makes it brittle. There is no real linear scalability to support the massive data volume, and it struggles with the lightweight analytics and things like that. On the other side, NoSQL, great. You don't have to worry about schema and brittleness, and I mean, it works really well for e-commerce because it's all read. Like, most of the things are read. Until and unless user will decide to buy that, it's all read. So it works really well for that scenarios. For normal IT, I think the expertise and drive to adopt this new technology and make the changes is one of the challenges. Like, it's not the technical challenge, but it's a challenge for sure. And sometimes limited query capabilities. And I think there is a lot of improvement in last few years in this area. Like, earlier there was not really any access control for NoSQL, but I think all these companies are making progress in that one. And migration is the key thing. If you are working on a new product, that was the thing with Pearson. I mean, working on new product and using NoSQL it was easier, but having something that is full grown and really change it to adopt NoSQL is quite a pain, I'd say. Again, with Hadoop, you don't have to worry about matching it and mapping it to different SQL and things like that. You can directly process the logs and tags, and it's highly scalable. Again, the expertise and all other things are the challenges here. If you have any questions, you can ask now. I would love to get your feedback if you think something makes sense, something doesn't make sense, this is not the direction we should go or we should go. Please send me an email. This is my personal email, but you can, it's deepali.trivedi@staples.com is another one. And that's all. Thank you. Thank you all for listening.